So we start with the application of the trigonometry, the general trigonometry, whereby we have part of our angle calculation to be 90 degrees. What we are supposed to first know is angle of elevation and depression. So basically, when we talk of angle of elevation, let's see demonstration. Probably Kofi is standing at this point. Kofi is standing here. This is Kofi. We try to see the top of a tree. This is a tree standing at this point. Kofi is able to see the top of the tree. This is the top of the tree. So, where he is standing away, according to his height. Okay, good. Let's see something like this. Good. So now Kofi raised his eye to a certain level in order to be able to see the top. So the elevation means raising the eye, raising. So as he elevates the eye, the angle covered here, if that place is, say, alpha, that is the angle of elevation. Now as he got to the top of the tree, the angle created here, there's another one which will be going backward. We call this angle as an angle of depression. The angle of depression. So the angle of depression is also the same as the angle of elevation. That one will also be alpha. But it's not always so, because the wielder of exam question will decide how you want the angle of depression to be. So if you are being asked, probably the height of Kofi is 1.2 meters. And then he is standing away from a tree whose height is not known. So this is Kofi's height, which is 1.2 meters. Why have I written the 1.2 meters here? Because you see, this section, we are getting something like a rectangle. So whatever is here is also here, and the length here will also be the same. So if he's standing away from the tree, let's say it is he's standing 5 meters away from the tree. If he has to raise his head through an angle of 38 degrees in order to be able to see the top of the tree, what will be the height of the tree? That's a simple question I've deduced. If he has to raise his head through an angle, like I'm raising my head like this, in order to be able to see the top, through an angle of 38 degrees, in order to be able to see the top of the tree, what is the height of the tree? Mind you, part of Kofi's height is also equivalent to a certain section of the base of the tree. So we can only calculate that using this section. So let's say this place is, say, H. So how do we get H? Now look at it. There are two types of figures. We have gotten a rectangle and a triangle at the top. Rectangular base and a triangular section. And we have just learned how to calculate the side. So if I just try to bring the triangle, if the triangle is like this, this perceived to be the triangle, yes. And where Kofi is standing, this section is vertically meeting the horizontal at 90 degrees. So it's a right angle. So this is 5 meters. And this is the point of Kofi's eye. So let me say IE. And the top of the tree, T. And then, let me say a certain part of the base, let me say B. Good. And he has to raise his head through an angle of 38 degrees in order for him to be able to see the top of the tree. So we have this figure. Now going back to be able to get our H. Where have we been given? And where are we looking for? We are looking for H, which we have H here. We need to be able to know the ratio, which conform with what? What the position here is opposite, this place is adjacent. So we say is opposite adjacent is tan. So tan 38 degrees is equals to, what is my opposite? H on 5. So H here equals to 5 tan 38 degrees. So we have H to be equals to, if you don't know, you just use your calculator to point, because you can't get it. So in this case, as we have been doing, we just take it this way. Just go to, just point 5, then on the calculator point the top, you see tan, you enter tan, then you put your 38 there, then you close your calculator, the bracket, then you are going to get 3.990. So we got 3.90 meters, approximately H to be equals to 4 meters. Good. But the height is not only H. The height of the tree, Kofi is standing a distance, so the height of Kofi is also part of the base of the tree. So if here is, say, A, and here is B, as I made B, and here is T, then here is the eye of Kofi. Then the total height of the tree is going to be AB plus BT. So let me bring that one. Therefore, the height, we are going to have the height to be equals to what? 80. The length 80, which is the same as height of the tree, is going to give me the length AB plus BT. And AB is conforming with the height of Kofi, AB. And BT is the height of the remainder, which is part of the triangle. So we've gotten 80 to be equals to, AB is 1.2 plus approximately 4. So in all, we're going to get 80 to be equals to 5.2 meters. That means the tree is very short. It's not that long. So it's quite long, but not that long. So we say a tree is 5.2 meters.